Welcome everyone to the webinar Sustainable Innovation in Urban Mining, Bridging Startups and Corporates. Happy to have you here all on board and welcome you to this webinar where we dig deeper into the topic of urban mining and present some challenges in this field and also some solutions provided by several startups already. And short introduction to the speaker and to me. I'm Mario from RootCamp. I'm mainly doing the scouting of the startups for the RootCamp, which is an innovation hub and startup accelerator in the field of bioeconomy, agtech, and circular economy. And I am moderating the session. We have 4 different speakers on the list, and we start basically with my colleague Philipp from RootCamp. He will give you a short intro about the activities of RootCamp, what we are doing, and how we actually bridging the gap between startups and corporates, and what are our main focus topics, followed by our partner Ralf from K+S. He's presenting basically the activities of urban underground mining from the perspective of the corporates. So K+S is a big fertilizer company, globally active, and gives an insight or a few insights into the topic of or the challenges and the trends of urban mining. Going further, we have Vika on board. She's from Refresh Global, a startup in the textile recycling industry. And afterwards, we have PROTEEN. So Tommie and Philipp are presenting the startup actually based in Uganda, focused on the waste recycling of organic waste. And after each of the presentations, which is around about 10 minutes, we have a few questions and also a bigger discussion at the end regarding different topics. What is actually the driver of the urgent topic of the urban mining, and what are different challenges, where do we see the trends, and where are big leverages to scale basically the urban mining or circular industry. That's enough from my side. I would now hand over to my colleague Philipp. You see already the screen, so feel free, Philipp, you have 10 minutes to present what RootCamp is doing. If you want, you can turn off the camera for the other speakers. And Philipp is basically in the big view. Thanks.
Perfect. Many thanks, Mario. Also, very welcome to the Urban Mining webinar. This is part of our reach out campaign for the actually 6th batch of the RootCamp Acceleration Program. I'd like to give you a very short introduction on what we are actually doing at RootCamp, how we are bridging between corporates and startups, and what our ecosystem development and also value chain mapping contribute to that. So first of all, we start with corporate innovation, venture clienting. That's how we started. Also the RootCamp. These are our partners. So initiated by K+S, we have other partners coming also from the agricultural side and many supporting ecosystem partners that just give us the opportunity to also support our startups there. And in the end, these corporates here are giving us actually the task, and we are looking for the solutions on the startup side. This is, as I said, part of our reach out campaign for the batch 6. So we are always collecting challenges from the corporates and are looking for solutions from the startup side. So we had an Ask Us Anything session that is recorded. So please ask us again if you want to have it repeated. You can apply to our 6th batch by May 30th. Just go on our website /apply now, and then you are getting onboarded on our application process. But why are we actually doing all that, and what have we done so far? So our program runs roughly 12 weeks over a time frame of 4 months. It is a hybrid program, partly in Germany here in Hanover, partly remote, because we have startups from all over the world that we invite. We support the startup with a travel grant if they come from further abroad. And that also explains the hybrid model that we have. So far, we have supported or accelerated more than 30 startups, always trying to bridge the link between corporates and startups. One very good example we have right next to Hanover, actually, there's an old mining site of K+S that is still running as a fully integrated industrial site. And actually, 3 years ago, Aquapurna, the founders of Aquapurna, were sitting here with a good idea with some drawings in the computer. Together with K+S, they actually are about to set up the first and the biggest European scaled land-based shrimp aquaculture farm in Europe. What you see on the left side is just a demo plant. On the right side, you see a small glimpse of the industrial side of the old mining site of K+S. And actually, the machinery is already there. So what is green there will be turned into a land-based shrimp aquaculture farm. You can already buy it on German retailers and next to you. So this was a good example. The volume is already more than 10 million euros. And what we are doing also is on top of this bilateral interaction of corporates and startups, we are looking for extending the ecosystems of other startups. So, for example, on the left side, you see one of our programs that just started this year. This is directed to Spanish food tech startups, and we are offering a landing pad here at Hanover to enable the startups reach out to the German market. So what we try to extend the original ecosystem of the startups in Spain. We want to increase the product market fit, looking for further markets, and also help them to sell and communicate the right program, the right product. And another program is called Smarterra. This is directed to build up the ecosystem, the agri-food systems in south of Italy, with some other partners from the northern part of Europe, like Sweden Food Tech Barbecue, and DK Ecosystems. Together with Italian partners, we are trying to bring the expertise and the experience that had been collected in our environment towards the region of south of Italy and scale there the environment and limit actually or reduce the limits of the region. So these are two examples on what we actually can do. And now I'd like to turn into the overall demand. Why are we all doing it? So everybody knows that the time of the fossil resources is actually something for yesterday. Now we have a different demand. We have a so-called food gap. So between 2010 and 2050, the demand of biological resources, so everything that is actually growing, that is being turned into food or feed, or actually also being used in construction, that is the demand is dramatically increasing. And how are we actually tackle this? So either you can increase the production. So the world is endless. We can increase it, definitely new crops, better production methods, and so on. We can actually change the market. So we can reduce the demand of certain very impactful products. But the third part is actually that we need to cut waste or use whatever is already there in the better way. And this is the link towards not only supporting bioeconomy startups that are based on biogenic feedstock, but also on circular processes to just be more efficient and in reducing the emissions of producing or delivering new input material that we normally use. And therefore, this is the rationale for our urban mining, since these circular processes or upcycling helps us to save the resources of the planet and lower emissions in the production system. One best practice we have already, or again, from the area or from the environment of K+S. So K+S is a fertilizer producer. Ralf will go a little bit deeper. What they can actually do is using large amounts of minerals, large amounts of potential fertilizer minerals, And in this example, actually Northvolt is a quite known company from Sweden. They are producing batteries, but actually batteries contain minerals, and when you recycle batteries, quite some minerals are actually the product or can be recycled. And this is part of what is in the middle. It's Cyanus fertilizer. Cyanus is helping to get the right minerals or the minerals in the right way out of these batteries. And the goal is actually to collect up to 100,000 tons, of potassium sulfate in 2024 into fertilizer. And this is then being done by K+S as a fertilizer company, up to a couple million tons of fertilizer they're distributing every year. And so this is a good combination of using a very focused resource, batteries, a good process, and then actually turning it into a market to be in the end more effective. And with that, I would really like to hand over to Ralf, who is giving us an insight into different areas and different resources. K+S as a mining company with many space of underground storage potential is actually having in addition to that, and what they intend to do with that.
Yes, thank you, Philipp, for this short introduction of our company. I will introduce myself. Before we start about urban underground mining, just thank you for having the chance speaking here at the RootCamp. I'm just trying to share my screen, so now it should fit. What I like to say first about K+S. K+S is a mining company. We have been a startup 150 years ago, so it's a very old business we are doing. We are digging for salt and for potash, and in this 150 years, we gained a lot of room underground. So it's open mining, open space mining, which we use for waste disposal. So that's a small kind of our business. K+S has a revenue about 4 billion euros a year, and our product range scales up to 7 million tons a year. So these are big numbers. We are scaling down to smaller numbers now. Speaking about the waste business, which I am the head of at K+S, we are speaking about round about 800,000 to 900,000 tons of mostly toxic waste that we dispose of in our mines. So I think that's a pretty good introduction for our project, Urban Underground Mining. As I just said, we are disposing of waste for a longer time, for 50 years now, and we are gaining waste back, currently in a very small amount. So what we do is we do a kind of urban mining. Speaking about urban mining in general, we are speaking in general about huge quantities which are landfilled above ground. That's an example for electric waste landfill. And a typical urban mining approach, this waste will be kind of processed. That's a crushing mill here. So, and after the processing, it will be sorted. So by machine or maybe by a mechanical sorter, kinds of the waste which are raw materials will be sorted out and then will be reused. So that's a typical urban mining. What we will do in our underground facilities is not really the same done by the materials, but the process is comparable. What we see on the left side here is a picture of waste that's stored away underground, so that's disposed of. It's not that chaotic like above ground facilities. So it's waste stored in barrels and it will be walled in after a mining chamber is filled. So this is waste containing raw materials, and our aim is to bring it back to the circular economy. The difference between the typical underground or the typical urban mining is, because it's underground, it's stored away in a mine. It's a salt or a potash mine, and it's monofraction waste. So it's one kind of waste with a chemical fingerprint. So we know what happens in each barrel that we stored away. And it's stored away in barrels or big bags, so it's not one big dump. These are packaged wastes we speak about, so it's better getting them back to the economy than having a big landfill where we have to dig off the waste. And last but not least, and that's a little bit, yeah, it sounds scary, it's toxic waste. But toxic means in German regulations that there are different parameters that above a typical waste, so it need to be treated and transported in a special way. And there are different, it's a range of toxicity from not so dangerous to very dangerous. We know which waste is stored away where, so we are able to challenge the risk, opening up this waste and getting back the raw materials. We already did urban mining underground. We had former projects. The first project started, as I remember, in 2004, and these are transformers. You see these pictures, electric transformers. They have been stored away because there were oil inside that contains a hazardous liquid. After recycling process has been identified how to get rid of this toxic liquid, the producer of these transformers asked us to get back these transformers to recycle the copper and the steel, what's the biggest part of volume in these machinery. So in total, roughly 60,000 tons of waste has been recovered from our disposal sites. 14,000 tons were transformers, and the other 20,000 tons were waste that contained raw material, what is currently and was in the past very high priced per ton or per kilogram for this material. These examples here, selenium, rhodium, and lithium, are the elements that our customers looked at and asked us to regain their former waste, which was then owned by K+S, from the deposit. Just showing in a very, very rough manner what we are doing. We are speaking about salt and potash mines. We own in total 7 mines, and in 2 of the mines we do waste disposal. The concept is the same. We have a customer delivering a waste that's packaged. It will be checked after it arrived. If it fulfills the criteria that it could be disposed of, we take a sample. That's very important for our next step in this presentation. We have a documentation. When the waste goes underground, it will be transported underground by trucks to the site, to the mining chamber where we do the landfill below ground. It will stored away, and then after that, the mining chambers will be walled in so that nobody could get in contact with this waste. The typical wastes are listed here. So that's fiber waste, that's electroplating waste, hardening salt residues. These are wastes from different industries we have here, but most of the waste we speak about is from the steel and metal and electro industry. And there are a lot of filter dusts coming from incineration plants. These filter dusts also contain not that much, but speaking about huge quantities we stored away, about a competitive amount of raw materials in this waste. So, and the filter dust. The next slide is not a slide, it's a short movie that I like to show. It's the first minute, it's just a 2-minute movie. First minute is part of a commercial for K+S, showing what we are doing and why it is safe, what we are doing with our underground disposal plants. And the second minute that's very important, because this is the requirement for getting the waste back in a manner that we could deal with it and in a manner that we could make a business with, hopefully with the help of somebody who could show us how to get into market with our waste stream. So I'm going to start this movie.
K+S mines potash and rock salt deposits. This creates underground openings which, after completion of the primary extraction, are perfectly suited for waste disposal. The salt deposits are sealed off against groundwater by layers of clay and are located more than 700 meters below the surface. These salt layers are up to 500 meters thick and absolutely impervious to gas, gigantic natural barriers separating wastes and biosphere. Salt exhibits a plastic reaction to forces moving the Earth crust. This ductility prevents the creation of crevices in the salt. The salt deposit is 250 million years old. Hazardous materials are effectively removed from contact with the biosphere, safety measured in geological time. This long-term safety is determined and analyzed for each location individually, a complex process done by highly qualified experts. Underground disposal facilities in rock salt are perfectly suited for toxic and water-soluble wastes. Explosive, highly flammable, and radioactive substances are expressly excluded from disposal. Also excluded are liquid wastes and substances that react with the salt rock. All delivered wastes are analyzed at the laboratory. The samples taken are then stored at the underground archive. This long-term memory provides information on all substances deposited anytime and comprehensively. All materials destined for underground disposal are packed in big bags, barrels, and steel containers. They are then transported several hundred meters below ground via a hauling shaft. Below ground, special vehicles transport the containers to their final destinations. The individual waste types are stored separately. Recovery of reusable materials is possible. Walls and salt dams are used to close off completely filled opening segments.
What is important for us is just showing that we are able, because we have acceptance control at the beginning, so we know the analytics of a waste, and we have a sample stored away of each waste we deposit. We are able to determine the chemical fingerprint of a waste, so we know exactly what is happening in each barrel that we dispose of. So what we also have, what's not showed here, is we have a kind of a plan where it is written where the waste is stored away. So in which mining chamber, which amount of waste is stored away. So we know exactly what the waste contains and where the waste is located. So it's easy for us identifying valuable elements like lithium or rhodium, what I mentioned before. So we also could size the available volume, if you're speaking about 2 or 3 barrels, or maybe 200 or 300 barrels, or maybe 1,000. So we could show, okay, we have this amount of this waste stored in this location with this amount of raw material. So, and then we could estimate the cost of recovery. as I said, the waste is walled in after the mining chamber is closed, so we know what to do to get to the waste that we like to recover. What we then want to do is provide the raw material to the circular economy. That sounds very easy, but in fact, that's the part that's not so easy for us. And that's the question for the RootCamp and maybe other companies or startups showing us how to do it. So we identify 3 typical ways where we could provide from the raw material. One is just saying a recycling specialist, look, we have this amount of waste with this amount of raw material inside. Is this one kind of waste that you are able to recycle? So that's a typical sales model. We say, that's the volume, that's the price, do you like it, or do you see any chance for a lower price having this waste recycled? It's not that intelligent because we are depending on the market, and if nobody is able to do this, the waste is lost. Second possibility is we offer this waste to companies with a special knowledge for this waste, so they know exactly, okay, these are filter residues, or this is hardening salt. I know everything about hardening salt, but I don't know how to recycle it. So then we could deliver the waste and also a technology, a recycling technology for getting back raw materials which are in this waste. But in this case, we need to know what's the proper recycling technology. So the third way is that we at K+S, which is a fertilizer company, and that's not our main business, therefore it's not that easy for us. We will build an own recycling facility, but not alone. We need a partner doing this. We need a partner who is able to recycle waste from raw materials from waste which were stored away. And we are looking for wastes with the highest yield, of course. So we are looking for waste with the raw material inside, which is getting as raw material the highest price, because this price should cover the recycling cost, the cost of recovery, and of course we like to earn some euros for getting this waste back. So, and that's my final my final statement. We are in the need of a partnership in recycling technology or in sales intelligence, helping us after we know which waste should get back to the market, how to get it into sales, or how to develop recycling technology, selling it with the waste, or at least how to do it by our own, but with which technology we could start over. So I think I ended. I hope I was in time. I didn't have a look at the clock. Thank you very much.
A bit over, but thank you very much for the presentation. It was actually pretty insightful, and yeah, you summarized it at the end pretty good. So you have kind of resources, or today's waste, tomorrow's resources, stored systematically in the underground, and you have the challenge to recycle or to reuse these resources that are underground right now. And that's the call from our side, from RootCamp. If you are a startup, another company having solutions in the recycling sector or connected sectors, feel free to apply. We are looking forward actually to your applications. The deadline is 30th of May, and you can just go on our website root.camp/apply now, and that's just a short application. And from that, thanks again, Ralf, very much. After having the K+S presentation now, we now come to the startup from Uganda. We have been in touch already for quite some time in the last months, because we are also doing another, or actually do the project together with you, or kind of starting it right now to include your organic fertilizer, which is based on organic waste from cities into the mineral fertilizer of K+S, or a subsidiary of K+S in Africa. And yeah, PROTEEN, I think, Tommie, you are presenting. The stage is yours. You have around 10 minutes, and I'm looking forward to your presentation.
Perfect, Mario. Thank you so much. Hi, everyone. My name is Tommie.
My name is Philipp.
And we are the co-founders of PROTEEN. At PROTEEN, we produce supercharged fertilizer, which is an organic monostream like city waste and other types of waste. And we turn this into a nutrient-dense fertilizer using the larva of the black soldier fly. The larva of the black soldier fly, it's an amazing insect, as you can see here in the circle of life. As you can see, as any animal, it starts as an egg, turns into baby larva, which is point number 2, which is the stage at which we feed different types of waste. PROTEEN started in 2017, and we have been using municipal waste since that time. Municipal waste is a really good source, and the larvae feed very well on it. In our case, we feed the larva, and we create one product, which is the larva manure, or the excrement, which we turn into a fertilizer. We've been working since 2017, as I mentioned. Fast forward to today, we have turned our process into a patent pending process, which should be, if all goes well, approved in September. So along the way, we've pivoted many times, first creating larvae for animal feed, but now fully focusing on organic fertilizer production. Here you can see an image of what it looks like. This is one of our greenhouses. You can see on the greenhouse floor is the waste, which is being consumed by the larva. And the larva, they consume this for a period of 10 days, after which we continue the process for a further 3 weeks. And in a period of only 1 month, we can make a really nice nutrient-dense dry fertilizer. And that completely revolutionizes the composting industry. So why do we do this? We have identified several challenges. The 2 challenges that we'd like to focus on are the first 2, which are the challenge for farmers and the challenge for input distributors. So farmers across not just Uganda, but across Africa, they really lack access to a high quality organic fertilizer. In general, fertilizer has very low use. So both chemical fertilizer and organic fertilizer. We of course focus on organic fertilizer, but there's a severe lack of access and distribution to get fertilizer to the farmers. So that's the first one. And the second one is for input distributors, which is, for example, the subsidiary of KNS in Uganda. They're called Grain Pulse. So a farmer, they need to reach the organic fertilizer, and that starts with the input distributors. So input distributors don't even have access to organic fertilizer at scale. And with our solution, we can solve these 2 problems directly. So in summary, what are we pitching and what are we talking about? We turn organic waste, we feed it to insect larvae, and we produce a supercharged fertilizer. And there are many, many benefits, which we'll shed light on. But most importantly, farmers and the end consumer care that it's an affordable product and that the product works. In this case, farmers care that they increase their yields. So with our product, farmers get twice the yield, and it's 30% cheaper than the chemical alternative. Here you can see a diagram of how our patented process works. Again, we call this supercharged fertilizer. In essence, we produce all of our fertilizer on site, which is very important. So if we work in a municipality, we work as close as possible to the markets which produce the waste. We also work with other waste streams like coffee or avocado. But the point is that we can have a decentralized system where we can feed the organic waste to our maggots in a greenhouse structure, as you've seen. And it only takes 1 month to produce, which is significantly faster than composting. So the benefits, the alternative, and therefore the competition for us, is the alternative to waste management. So naturally, when you think of organic waste, it gets composted. And the big problem with composting is that it takes a lot of time. So our process takes 1 month, while composting takes 5 months. And the faster the process, the less space you need. The less space you need, the less capital investment you need, and the more flexible you can be in terms of location. A city, for example, of course, real estate is expensive. So you want to minimize the real estate and then maximize the output of fertilizer. Another unique selling proposition of our product is that of course, we work with the black soldier fly larva, and the black soldier fly larva, they contain chitin. Now, chitin is a fibrous substance which you can find both in the insect exoskeleton, but also in fungus. Now, the reason that this is important is because soil benefits hugely from fungal activity. And so if you maximize the amount of chitin into your soil through this organic fertilizer, you maximize fungal activity. And the more fungal activity, the happier the plant, the more yield, and the stronger the soil. As I mentioned before, our fertilizer works. So we've been doing field tests on coffee for a period of 3 years. This is with a partner company. And as you can see very clearly, our fertilizer, which is number one, has outcompeted all the alternatives. And for us, the most important competition is number 5, which is chemical fertilizer. Both from a sustainability perspective, we want to offer an alternative, and also because it's significantly cheaper than chemical fertilizer. And as Mario mentioned before, we as PROTEEN are actually already part of the RootCamp accelerator. We are about to start, and the project that we are focusing on is we call it the best of both worlds. So we're blending our supercharged organic fertilizer with KNS's organominerals. And the big benefit, or the major benefit, is that our chitin-enriched supercharged fertilizer really enhances the uptake of these organominerals. So although they both work well individually, together they work much better. And as you can see at the bottom of the slide, it's also about the application rate. So by combining our product with KNS's organominerals, we reduce the application rate per tree. And that just means that you have to bring less fertilizer to the farms. And as everyone knows, last mile distribution is already expensive, especially in rural parts of Africa. So now we can get less fertilizer for the same or better effects to the farmers. And of course, the price is important. I mentioned before that it's cheaper. So I mentioned it's cheaper than chemical fertilizer. So if you look at the bottom again in the orange, you can see that using supercharged fertilizer, our product, it costs $17 per tree. And with the blend of the KNS organominerals, we're looking at $13 per tree. And of course, you know, when you're working with 400, 500, 600 trees per acre, this really adds up for a farmer. So PROTEEN, we've patented our process last year, and since then we've been looking at different organic waste streams. We've started with municipal waste, and we're still continuing with municipal waste, but also we're looking at other waste streams like avocado, which comes from the avocado oil process, jackfruit, which comes from the dried fruit production of jackfruit, coffee, the red coffee cherries. And as I mentioned before, we do this on site. So here we have 5 sites. This is in Uganda, and we also have sites operating in Rwanda. The economics are important. At the end of the day, farmers don't buy the product because it's sustainable. They don't buy it because it's green. They buy it because it's cheap. And unfortunately, the cost is still more important than the profit per acre. That being said, we know this, and we also work around this. And our product is cheap enough that farmers are interested just by looking at the price. So we can produce our product for $86 per ton, and we sell it for $180 per ton. So we have a $93 margin, and this really allows farmers to buy our product versus the chemical alternatives. So we have been operating in Uganda for a period of over 5 years. Since last year, I mentioned we've really pivoted to pure organic fertilizer production, and our prospect for the next 3 years is that we can generate $2.2 million revenue just from Uganda alone, and that's mostly looking at coffee, avocado, and then dried fruits, and also our municipal introductions. So we are already in Rwanda, but for the next 3 years, we're also forecasted to grow in Rwanda. Smaller growth in Uganda for several factors, also population and size and opportunity. We're looking at $430,000 revenue growth in Rwanda. Then very excitingly this year, we've signed our first partnership with a company in Kenya, which will allow us to license our technology to this Kenyan firm. Kenya has huge opportunities for organic waste production and for farming, organic farming. So using a licensing model, we're aiming for $700,000 of revenue just in Kenya alone. Now, lastly, a call to action. We share this with partners, with investors, with other people that are interested. But of course, we're always looking for investment. But most importantly, our business model is a joint venture approach. Like I mentioned, we work on site, and we also want the waste producer to benefit from our solution. And the business model varies. Who invests in the capex, who shares in the opex, and we have different types of financing options. But it is very exciting, and it also allows us to rapidly expand throughout East Africa. So that being said, thank you very much, and thank you, Mario, and thank you for the team for this opportunity.
Perfect. Thank you as well for the presentation. It was pretty nice to see what kind of progress you already did. And before jumping to the next startup, I just want to ask already one question, because from our part, there are many or a few different drivers that impacts the drive to urban mining, or in general more sustainable use of resources. And the question here is because you were also so much talking about the financial figures behind it, what is actually the reason why you are able now to do it cheaper compared to traditional fertilizers? So is it the technology push, or is it a regulation happening in Africa, Uganda especially, or because you said already the sustainability aspect is, at least in your market where you are active, it's not the key driver for the farmers to use your product?
So I'm just going to stop sharing my screen. Yeah. So Philipp, if you'd like to jump in.
Yeah, perfect. That's a really good question. So our system was specifically from the beginning on developed to be low in capex, which also means we were looking at a low-tech solution that is in principle very low-tech, but can be easily mechanized by just using off-the-shelf machinery. So nothing new needs to be developed. And depending on where you are, for example, we are operating in East Africa, so we don't need a high level of mechanization. Actually, the tasks can be performed through manual labor, which is very good for the situation here, for the context here, where jobs are required. And that is, that the combination of low capex and basically really improving at large a already existing process, which requires only little R&D, allows us to really allowed us to really lower the costs.
Okay. Yeah, thank you. So it's rather a kind of just a different approach that enables you to do so. Yeah, perfect. Thank you very much for your presentation. And now I would like to jump over and introduce the next speaker. It's Vika from Refresh Global, and you are active in the textile recycling industry. I hope you are there. You can hear and see me and be ready to start.
Absolutely. Yeah, thank you so much for having me. Thank you for letting me be part of this really, truly interesting discussion. And I hope that I can also offer, another perspective and also another solution of how we actually tackle one of the biggest problems out there, which is textile waste, and the complexity of a new market that it will for sure be badly needed, because in the end of the day, we will need to find solutions of how we deal with the waste that the industry leaves behind. and find the best way to valorize it so that more and more stakeholders in this industry will get interested and can join and make this a truly successful opportunity. So this is what we do at Refresh Global. In the end, we have developed a technology, but we also have developed a whole new approach at what we call the circular city, meaning in the end of the day, how do we look into the waste that the city leaves behind and create these new opportunities from it, especially when it comes to textile waste, which, by the way, have gotten to become almost 10% of all municipal solid waste. And we know that the numbers will be rising. So just to understand a bit the big complexity of this industry, is that worldwide we're talking about almost 100 million tons of textiles that I don't think anybody can even imagine how big it is, but it's out there. And the problem is also that in the Western world, we don't see much of it. Why? Because the majority of the unused, unwanted textiles, not sold textiles, and so on, go into landfill incineration or are being sold to Africa. Now, the differences in the ability to recycle textiles are huge. So that means that there are countries which have a rather well-organized collection system for textiles, for clothing, but then there are other countries which hardly have anything like that installed. And so you can see mountains of unwanted textiles which are being burned from time to time. And it's a true ecological catastrophe that we're looking at. So for us at Refresh Global, the problem was so clear that we were completely driven by the need to find a solution which could tackle really the majority of the textile waste. We really wanted to see how we could offer a solution which is as universal as possible and also as applicable as possible on the local space. And of course, also in the end of the day, we see that there's a huge incentive by reusing and valorizing the waste that a lot of the stakeholders can benefit from. And we're not the only ones who have understood the urgency and also the need. Actually, in the European Union, starting next year, so only in about a few months from now, it will be actually an obligation to start installing take-back systems, circularity. It will be forbidden to landfill and incinerate textiles. And so, as you can see, there are even countries which are already starting to implement or started implementing part of this regulation. But in the end of the day, we're looking at 27 countries that are going to start installing a whole system to start collecting the waste. But we know that only actually maybe a handful, if at all, have any kind of real reasonable solution for them. So this is why we have to actually work very fast to start implementing solutions in the ecosystem. Now, I guess one of the layers of the complexity, which we also are looking at to help out with, is the fact that the fashion industry is, while being the one with the biggest problem, of course, they're the ones that own most of the textile waste out there, but it has been taking them traditionally a longer time to start implementing innovation. So as a result, we said, well, there are other industries which are in the manufacturing space, which actually already have done more research, have done some changes in their mindset and policy, and understand that they have a need to start implementing recycled materials in their manufacturing. So basically replacing their current practices with a new sustainable way. So this is how we actually invented what we call the open loop approach, that in the end of the day uses our invented process, our biotech process, to take textile waste and to manufacture new raw materials from it that can then serve in actually over 14 new industries. And we are a team of people that includes chemists and engineers and people that understand manufacturing. So for us, it was very important to have a team that understands all the aspects of what we want to do. So the way it works is that if, as I had mentioned before, until now, over 80% of our textile waste goes into landfill or the other non-sustainable solutions, we are now coming in with our refresh open loop technology. And what this technology knows to do, it diverts the textiles from landfill. It knows to do something that is especially needed and is one of the most important pillars of innovative textile recycling, which is separating between natural and synthetic fibers. And ultimately, it manufactures 3 new raw materials from it that are then being used by over 14 new industries. And just to quickly understand how this looks like and what are the 3 new raw materials. So everything that is synthetic comes out sanitized from the process and turns into what we call resin pulp. So it's a sanitized textile pulp, which we can then apply back into the textile industry. And everything that is natural turns into a product that's called nanocellulose, actually a very promising material, which is going to replace plastic application and will become like a bioplastic type of product. And then we also have the ability to take the waste from the nanocellulose process and distill it into ethanol. So we are actually the first ones in the world which have successfully developed ethanol from textile waste. And as I mentioned before, we have over 14 industries which are benefiting from this. Why is this important? Well, clearly, if in sort of the most classic, let's say, approach is about trying to close the loop by taking yarn and create yarn from it, taking certain types of textiles and making the same type of textiles from them, which is a fairly difficult approach and will probably take quite some time until this is going to be successful. We are already able to actually manufacture these materials, offer them to these different industries, and hopefully by that increase more and more the volume of recycled materials in manufacturing. And every product in the end of the day has its own market and can have its standalone industry and opportunity. But our first has actually gone into the automotive industry. Now, traditionally for many years, there has been some downcycling in textiles, and that's because it's been the only way to recycle it was through mechanical tearing, and there wasn't much room for innovation. Whereas what we have done was to actually take some of the more challenging car parts and manufacture materials for them which could truly pass the test of anything that, as you probably can imagine, a car would need, a car part would need. So that has already happened. And actually, there are over 40 textile parts in a car on average. So we are now working with numerous car brands, automotives, that are interested in us helping them finding solutions for different types of parts. But we have also done other collaborations because we truly want to help as many industries as possible benefit from our solution. And here you can see collaboration with a manufacturer of acoustic cabins, like I'm sure most know. And of course, there too inside, next time you go in one such cabin, you will actually see that this is made from textiles. So here's the first spoof in the world that has been made with recycled materials. And we've done also collaborations with the fashion industry and many others. So in the end of the day, we really wanted to show that this is possible because there's a good business concept behind it. And maybe I will just summarize that for us, what's most important is that we can show that we can take in almost any kind of textile waste. And the solutions we're providing in the end of the day and what we will do also in the future is what you saw how the technology looks like. We call it the Smart Up system. And this is what ultimately we're going to provide worldwide to customers. Today already we have potential customers contacting us from India, from the United States, from so many different locations, because they know that they have the quantities of the waste and they want to try finding a solution as soon as possible. So our next milestone after we will continue increasing our revenue and we'll successfully sign a couple of development contracts for delivering the materials and scale. The next milestone after that will be actually beginning to build the demo system, which will most likely be based in Germany with some partners, which we're already beginning to work with together. And then in the end of the day, we're going to start distributing our SmartTap system worldwide. Yeah, thank you very much.
Thank you very much, Vika, for the great presentation. I really like your design. So you were talking about all the, like, obviously you are in the textile waste industry, and I think the amount of waste in the textile industry is actually pretty big. So there's probably no need for you right now to think about different waste sources. But did you try already your biotechnological process to use different inputs, basically, not only from the waste industry, but from other industries?
Well, as far as we're concerned, we're open to take in any kind of textile waste types. This is anyway our biggest goal, is that we can provide this broad solution. Yes, there is quite a big variety of requests. Some are more interested in separating between different types of polymers. Others have a problem with glue, for instance, when it comes to industrial textile products and the waste of. But the biggest problem, actually, if you're looking at volume-wise, is the one that comes from post-consumer. It actually comes from clothing. And that is the one that is usually in mixed composition. It has a mixed composition of cotton, polyester, or something similar. And that is the one what we are actually looking to tackle the most, because this is, again, the biggest problem.
Yeah, makes totally sense for me. Okay, perfect. Thank you very much once again for the presentation. I will quickly summarize the entire webinar, since we are already a bit over time, and yeah, we don't unfortunately have any time more left for the discussion. So we had at the beginning presenting Philipp from RootCamp, so my colleague, explaining what we are actually doing and yeah, how we support startups and connect them with the corporate industry, especially in the bioeconomy, edtech, and circular economy sectors. Afterwards, Ralf from Campus S was presenting. They have basically, so actually Campus S is a fertilizer company in the first line, but they have old mining sites where systematically waste are stored and are just waiting to be recovered to the top of the earth, basically, and to get the the important resources again out of the waste. And followed by Philipp and Tommie from PROTEEN. They are active in Uganda and use city waste, organic city waste, to transform it into fertilizer for the growing crops, basically. And last but not least, we had Vika before I was speaking right now. She was presenting their approach from Refresh Global to recycle in a biotechnological process textile waste into different products for different industries. And yeah, that should just give you some insights about the topic, the very broad topic of urban mining. And we as RootCamp, we are looking basically for startups working in the topic of urban mining, not only restricted to that, but also in agtech and bioeconomy. But especially for urban mining, this webinar is used to give you some insights what our corporate partners are looking for, actually, and yeah, what challenges they have. that can be potentially solved by you. So we are looking forward to your applications for our 3 months cost and equity-free acceleration program. The deadline is the 30th of May, so around 3 weeks left. We are looking forward to it. And once again, thank you for participating in the webinar. Thanks again to all the speakers. And yeah, see you somewhere on the screen or even better in person here in Hanover. Bye-bye.